In the last video for this section, we're going to take just a little bit of time to talk about the mean and the standard deviation of a binomial experiment. So working with the same problem that we've seen in the last couple of videos, we've got a student admitted to an Ivy League school is about 17%, and we've got our group of 10 students that apply to the school. So we have, in this case, n equals 10 is our number of trials, and the probability of success p is 0.17. Now notice I didn't ask anything about how many students get admitted to this school. I don't necessarily need to know the number of successes here. The only thing that I need for mean and standard deviation are the number of trials and the probability of success p. So first up, let's talk about the mean. The mean, another way to talk about the mean that we saw in the probability section is you can think about it as the expected value. So when we talk about the mean, we can think about it as the expected value. In this case, it would be, well, how many students would we expect to be admitted to this Ivy League school? Out of our 10 students are applying, knowing that there's roughly a 17% chance for any given student to be admitted. Well, in this case, I know that I've got 10 students, about 17% are going to be submitted. I'm just going to take the number of trials that I'm running n and then multiply it by the probability of success p. So in this case, that would look like n times p, that would be 0.17. If I multiply that out, I should end up with simply 1.7. So our mean in this case is 1.7. Now you might think to yourself, hey, that doesn't really make a whole lot of sense here because we're really talking about the number of students here. And we can't have a decimal number of students. And I would agree with you there. I think in this case, when we're talking about binomial distributions and talking specifically about mean and standard deviation, it's okay to have a decimal for these answers because we're really thinking about the distribution. Obviously, you can't have 1.7 students admitted to a university, but that is the mean of this particular distribution, which in this case, we're never going to see in the real world, but it's what we would expect to see given a perfect distribution here. If you wanted to interpret this, if you wanted to talk about this within the context of the real world, you could say, yes, we would expect either 1 or 2 students admitted. And you could round that up if you wanted to. I might just say between 1 and 2 for right now. But if you wanted to interpret that number within the context of your problem, yes, we would want to round that either up or down to the nearest whole number or say between these two numbers. But yeah, we can have a decimal when we're talking about mean and standard deviation of a binomial experiment. So the next thing that we need to talk about then is the standard deviation. When we talk about standard deviation, remember standard deviation is a measure of spread. It tries to talk about how much variation there is in our data. In this case, we're going to use the formula the square root of n times p times 1 minus p. So I'm going to take n, which is our number of trials, we said 10, times p, the probability of success, 0.17, times 1 minus p, 1 minus 0.17. If you wanted to take a moment just to work this out, it should be 0.83. Or if you're okay typing this all in the graphing calculator at once, I would just say, please make sure that this part right here is in parentheses, otherwise you will make a mistake. It's an easy way to make a mistake in these problems. But I'm going to grab my graphing calculator and say 10 times 0.17 times 0.83 should give me 1.188 if I round to 3 decimal places here. So this would be my standard deviation is 1.18.